Let's discuss some prerequisites, what we already know. If you don't know all this before going to this chapter, it's good that you should go to this chapter. What we already know is, we know how to find derivative of composite functions, inverse functions, trigonometric functions, implicit functions, exponential functions, logarithmic. So if you know how to find derivative of all these kind of functions, we can start with this chapter, that is application of derivatives, because in these chapters we'll pretty much use all of these derivative. So if you don't know any of these, please watch the previous lesson where we have discussed how to find derivative of these kind of functions. So let's start with the chapter. What we'll study, we will first do the introduction. We will study the use of derivative to find rate of change of quantities. We'll study how we can use derivative to find increasing and decreasing functions. We'll study again derivative to find tangents and normals, to find approximate values, and to find maxima and minima. So application of derivative, as we all know in real life, you have this car and you want to find if you have this distance time graph, from this distance time graph you want to find the speed in a particular point in time, you can find the derivative at that point. That will give you the speed at that time. If you have velocity time graph or speed time graph, you want to find the acceleration, you can just find derivative at a particular point, you'll get the acceleration at that point. So same thing in the field of space, we use this. In field of chemistry, the rate of change of things, as I discussed, right? You use derivative. You have this graph, you want to find the maxima value, the minima value, those kind of stuff we do using derivative. For weather forecasting also we use. Also, as I discussed, if you have this function and you want to find whether it is increasing or decreasing function, we use derivative. Or let's suppose you have very complex number, no, root of, let's suppose 99999.8, such kind of functions you have, and you want to find the approximate values of these, we can use derivative to find approximate values of these functions also. So maxima, minima use, rate of change we use, and to find the slope we use, to find approximate value we use. Also, if you have this let's suppose curve, this is the curve, you want to find tangent, equation of normal, all these things we can use derivative. So we'll explain all these things one by one. So to start with, application of derivative is used to determine rate of change of quantities. It is also used to find, as I told, equation of tangent and normal to a curve at a particular point. Please note tangent or normal to a curve at a point, because when I'm talking about tangent or normal, I'm talking about at a point, because at this point this is my tangent. For the same curve at this point, this is my tangent. So the tangent and normal varies from point to point. So this is a must. Also, it is used to find approximate values. We'll discuss more about all these things. It is also used to find the turning point in the graph, and that is used to find local maximum. For example, you have this kind of functions and you want to find what is the maximum value, what is the minimum value. We can use derivative to find such kind of values. We'll also use derivative to find whether the function is increasing or decreasing function. For example, this is my graph and this is my function, right? So if you see this kind of function, this guy is increasing from this interval to this interval, correct? And it is decreasing from here to here. So if I want to find which interval it is increasing, which interval it is decreasing, those kind of things also we can find using derivatives. So these are some of the practical application of derivatives in a real life: the rate of change of quantity, equation of tangent and normal, approximate values, maxima and minima, smallest or largest value, or increasing or decreasing function, correct? Rate of change of quantities. Let's take one example. So if I have my general equation, y is equal to fx be a general equation I have, and now in this case it says y varies with x. So both are dependent actually. It is not that both are independent. It is a function where y varies with x. Both are dependent. For example, let's suppose y is equal to 3x square plus 2x plus 1. This is one example where y is dependent on x. So one equation of y is equal to fx form where y is dependent on x. Then my dy by dx we have studied is nothing but f dash x. Now dy by dx at some point x is equal to x naught is nothing but f dash x naught. This is also we have learned. Also, if you have two variables and where x and y vary with respect to t, x and y are not directly linked, but they are indirectly linked with respect to t, where I say f is equal to x is equal to ft and y is equal to gt. That is, for example, I say x is equal to 3t square plus 4t, correct? And I say y is equal to tq. If you see, x and y are looks independent, but internally they are dependent because they both are dependent on t, correct? So in that case, if you see, I can use this formula. If I want to find dy by dx, I can get first dy by dt and then I get dx by dt. You divide both, you get dy by dx. And the assumption is dx by dt should not be equal to 0 because this comes in denominator and this becomes infinite value. So rate of change of quantity, if you have y is equal to fx, right? If I have to find rate of change of y with respect to x, I'll say dy by dx. So this is nothing but rate of change of y, and this will say with respect to x. So whatever comes in denominator is with respect to, and whatever comes in the numerator is rate of change of that quantity. For example, I say dA by dB. If I say, that means rate of change of A with respect to B. If you make a small change in B, what change it will have in A? dA by dB, rate of change of A with respect to change in B. So we have, for example, I have distance time graph, right? I have x is equal to distance, t is time. So when I say dx by dt, I'm saying rate of change of distance with respect to time, and this is nothing but speed, correct? So dA by dB is nothing but rate of change of A with respect to B. This can be used for any variable A and B where A and B should be linked. If A and B are not linked, this is 0. For example, I'm having x is equal to, let's suppose, 3k square plus 2k, correct? And y is equal to, let's suppose, 2t plus 5t. And k and t are independent actually. If you see, x and y are also independent now. In this case, my dy by dx will be 0 because you make any change in y, any change in x, they are independent of each other. So these things has a value only if both these quantities are related. If a and b are linked, then it will have some values, or else it will be 0. So to understand the concepts better, the question says we have to find the rate of change of area of circle per second with respect to its radius. Understand this, the terms here is rate of change of area of circle with respect to radius. That is, let's draw a circle first. So this is my circle and this is my radius r. Let's A be the area. Area is nothing but pi r square. The question is asking me what is the rate of change of area of circle. That is, I told dA by dB, this is nothing but rate of change of A with respect to B, correct? So here rate of change of area they are talking about. So they are talking about change of area with respect to, here B is nothing but radius, dr. So this is the quantity they are looking for when r is equal to 4. That is, r is equal to 4. So this is my answer. This is my answer. Why? This is the quantity they are looking for. Now we have to find the value. I know A is nothing but pi r square. So this is nothing but d of pi r square by dr at r is equal to 4. correct? So if you find the d of pi r square with respect to r, pi is constant, r square becomes 2r. How come? D of r to the power n to the by dr is nothing but n r to the power n minus 1. Correct? This is the formula we have. If you don't understand this, please watch my previous videos where I explain how to find derivative. So this is what you get. That is n is 2, r to the power 2 minus 1 is r to the power 1. That is 2r. So pi 2r is nothing but d of area with respect to r. And we have to find this at r is equal to 4. So this is nothing but pi into 2 into, instead of r I'll say 4. That is nothing but 8 pi. And that is my answer. Now what is the unit? We are talking about rate of change of area per second with respect to radius. Meter per second. Why? Because if you see this guy is in meters. If you see, it is meters, only one r component. This guy's area is meter square. If you see, this unit of this will be in meter, and talking about per second, so you can write per second. So please don't get confused with per second here. This is just to confuse you. The question says rate of change of area with respect to radius. So that is, we are finding dA area by dr. D area by dr is nothing but d of pi r square by dr. We use the derivative formula to get the value as pi into 2r, and then we replaced r with 4 and we got 8 pi as the answer. Let's take one more example. The question says the volume of the cube is increasing at the rate of 8 cubic centimeter per second. We have to find, this is cubic, we have to find how fast is the surface area increasing when the length is 12 centimeter. So let's understand the problem. The question says, the keywords here are the volume of the cube increasing at the rate of this. We have to find surface area, how fast surface area is increasing when the length is 12 centimeter. The question is something like this. This is my cube, correct? Now the volume is increasing at the rate of 8 centimeter cube per second. It means d volume by dt, because change in volume with respect to time, because it is, if you see, per second, this is volume, unit of volume, this is unit of time. So it is d volume by dt. This is the critical thing here. We don't understand this, the solving problem will be difficult. If you understand this part itself, this question is nothing. Let's understand once again. The volume is increasing at the rate of 8 centimeter cube per second. That means I'm talking about change in volume with respect to time. That is d volume by dt. And this is nothing but 8 centimeter cube per second. This is given to me, correct? Now the question says how fast is the surface area increasing. That means I have to find d of surface area with respect to dt. Why? Because it's saying how fast. Fast is nothing but change of surface area with respect to time, because fast, slow, this denotes time. How fast is surface area is increasing when the length of edge is 12. So you have to find d of surface area with respect to dt, where L is equal to 12 centimeter. Correct? So the question is d volume by dt is nothing but 8 centimeter cube per second. We have to find d surface area with respect to dt, where L is equal to 12 centimeter. So if this part is clear, the question is very simple. The formula of volume for this cube is nothing but V is L cube. If let's suppose the length is L, all the lengths are L, correct? So V is L. What is surface area? Is nothing but 6L square. These formula we know. So the first question says d volume by dt is this. We have to find this. So we can find out from these two that we have to find one equation in terms of L, because see, we have to find this value d surface area by dt, correct? So this is nothing but d of 6L square by dt, and I'm saying that length is changing with time. This is nothing but 6 into t square become 2t, sorry, 2L square becomes 2L into dl by dt, correct? I have to find this guy where L is equal to 12, correct? L is equal to 12 I can put here, but still dl by dt is a quantity which I don't know. See, the question says I have to find change of surface area with respect to t. Surface area is nothing but 6L square. So this becomes 6 into L square became 2L into dl by dt, correct? So this guy dl by dt is something which we don't know. How can we find dl by dt? We can find using this equation, correct? This is equation 1 and this is equation 2. From equation 1 I can find. So let's take this equation 1. Volume is nothing but L cube. So this becomes d volume becomes d of L cube by dt, that is nothing but 3L square into dl by dt, and the value of this is nothing but 8 centimeter cube per second given. So from this I can say dl by dt is nothing but 8 by 3L square. So this is, let's suppose, my third equation. So this is my fourth equation. I found dl by dt in terms of L, and that's solved my problem. So I can combine third and fourth, so I'll get my d of surface area by dt will be nothing but 6 into 12 into dl by dt is nothing but 8 by 3L square, correct? 3 and 6 I can cancel 2. So this becomes 8 into 2, 16 into 2, 32, and this becomes L and L square cancel, 32 by L, correct? And what is the value of L? L is 12 centimeter. L is 12 centimeter. So this is where L is 12 is nothing but 32 by 12, and that is my answer. So what we have done here, change in volume with respect to time was given to us. So we just kept it. We were asked to find change of surface area with respect to t when L was 12. We used the formula of surface area as 6L square. We found change of surface area with respect to t comes out to be 6 into 2L into dl by dt. We know the value of L, but we don't know the value of dl by dt. Where to find this? What we did was, we knew that the volume is L cube. So d volume by dt is nothing but, when I found this is nothing but 3L square dl by dt, and that is 8. From this I found dl by dt came out to be 8 by